Dear students, welcome to our class on JRF SRF Net 2022, latest general knowledge. After learning reasonably good amount of information on different crops, how they have progressed after the independence, particularly comparing a situation of 1950-51 to 2020-21. We try to understand different crops, their performance and present status. In this, the last one is the techniques of breeding, how they are transforming our Indian agriculture. There is a possibility for a bit or two on the genetics and plant breeding side of the competitive question paper setting. So, unless we know it, we are not fulfilling the minimum obligation of covering genetics with reference to crop improvement, crop prices and adapting to the climate change. Now, so in this class, we try to understand new breeding strategies which are being followed in the country. As I said a half minute back, a question or two, okay, is most likely to come. That's why I am covering in this class new breeding techniques with reference to crop improvement. Now, first one, new breeding strategies. Number one is genome editing. GENOME, genome editing. What exactly is it? Precise genome editing has great significance in crop improvement. Different crops have been benefited by genome editing through the use of engineered nucleases. Okay, of them, for example, zinc finger nucleases, transcription activator like effector nuclease, and this third one, please listen very carefully. If time permits, please write also. CRISPR, CRISPR. What exactly is the expansion for this one? For this acronym, what is the expanded form? I repeat it twice. Please write. Recently introduced one. This is the recently introduced one. Clustered, regularly intercepted, short, palindromic repeats. I repeat once again. After zinc finger nucleases, effector nuclease, the third one is CRISPR, CRISPR. What exactly it stands for, I explain to you later. Clustered, regularly intercepted, short, palindromic repeats. So this is recently introduced technique in genome editing, which helps a great level in the crop improvement. So then genome selection. After genome editing, genome selection. What we are trying to understand in this class is what is the way forward. Okay, for us to improve our production, productivity, nutrient quality, value addition, for all these things from the genetics and plant breeding side. First thing is genome editing. Second one is the genome selection. Genome selection. Now here, very interesting thing is few recent initiatives such as excellence in breeding. In short form, we call it as capital E, small I, capital B. Okay, excellence in breeding platform of a consultative group of international agriculture is the CGIAR. That's what we call it as. Few recent initiatives such as EIB, excellence in breeding platform of a consortium. Okay, a consultative group of international agriculture research and ICR-led consortium through financial support from Bill and Melinda Gates Foundation. They have initiated this one. Now, the consortium is aiming, for the application of next generation breeding, genotyping and digitalization approaches, improving the genetic gains in Indian staple food crops, that is paddy, maize, wheat, commercial crops, cotton, of course, oil seed and pulse crop, both soybean, for example. Okay, however, the initiatives are at infant stage as of now. So that much contemporary, you should know, my beloved student, you should know. What is that one? Genome selection. For genome selection, CIGAR, okay. CGIAR and ICAR, they are leading a consortium for aiming is for the application of next generation breeding. So this is the thing. After genome editing, genome selection, third one is the accelerating genetic gain through speed breeding. Okay, accelerating the genetic gain through speed breeding. So to meet the demands of the changing climate, in other words, changing demands for the foods, changing types of food processing. For all these things, accelerating the genetic gain through speed breeding is the other one we should know after genome editing and genome selection. What is this one? What is accelerating the genetic gain through speed breeding? In order to accelerate breeding program, the concept of recently developed speed breeding method, which uses environment controlled growth chambers that can accelerate plant development for research purposes, including phenotyping of adult plant traits, mutant studies, transformation developed in wheat and other crops offers great scope for improvement in other crops. So what I would like to impress upon you is that in the way forward, what exactly are the things we should take from the genetics and plant breeding side? Of them, number one, genome editing. Second one is the genome selection. Third one is the speed breeding. Next one is the transgenics. It's very interesting. Most of you may have done some minor courses in that transgenics from genetics and plant breeding side, you must have heard. But important things from the BITS point of view, I would like to cover. India stands 5th in the world for area under transgenics. India ranks 5th in the world for area under transgenics. The single genetically modified crop, cotton, is developed by incorporating genes from the Bacillus thuringiensis, BT we call it as, capital B, small t. Okay, the Bacillus thuringiensis is a soil bacterium harboring a gene found to provide resistance against Heliodis bollworm insects of the crop. When Heliodis is attacking cotton crop across the globe, across the countries, it is causing enormous amount of loss of the economic product of cotton. That's why BT cotton, BT cotton, Bacillus thuringiensis is developed and it is reaching the doorsteps of the farmers in a big way. At present, under the genome, of course, genetic modification or genome breeding and whatever the steps, even including speed breeding, when we go for speed breeding also, these are all done for the improvement of crop production. That's why genes play an important role. This is the philosophy in transgenics. What is the philosophy? The genes that are controlling one side any pest or disease, the other side the weedicides. These are the things that genetically modified crops are being seen. Now, see, India stands 5th in the world for area under transgenics. The single genetically modified crop, cotton, is developed by incorporating genes from the Bacillus thuringiensis. The BT is a soil bacterium harboring a gene found to provide resistance against Heliodis bollworm insects of cotton. Now, at present, the genetically modified crops are grown globally in 190 million hectares. Genetically modified crops are grown in 190 million hectares. This bit is likely to come. The area under genetically modified crops across the globe is dash 190 or multiple choice. A question may come like this. That's why. However, if you take the descending order, soybean, genetically modified crops area, soybean 49%, followed by maize 31%, followed by cotton 13% and canola 5%. So these are the crops that are grown under the BT, Bacillus thuringiensis, genetically modified. In other words, genetically modified crop, Bacillus thuringiensis with reference to cotton. Now, the most frequently used genetically modified traits in these crops included insect resistance and herbicide tolerance. This bit is likely to come. In all these crops, soybean 49%, maize 31%, cotton 13%, and canola 5%. All these are these are most frequently used genetically modified traits in these crops included insect resistance and herbicide tolerance. This is the thing that I told you 1.5 minutes back. In India, two genetically modified crops, that is Bole Gourd 2 Roundup Ready Flex BG2 RRF and mustard are under regulatory consideration. The BG2 RRF cotton incorporating BT as well as the glyphosate tolerant genes is developed by Monsanto, and whereas the transgenic mustard harboring 3 aligned genes that enable higher yields through hybridization is developed by Delhi University's Center for Genetic Manipulation of Crop Plants. Now, so let us see with reference to the diversification and evaluation. See, the food hobbies of the population across the country, across the globe is changing. To meet the demands of changing food habits, keeping in view their health, diversification and valuation is being attempted by genetics and plant breeding scientists. Currently, research efforts on the development of value addition are gaining attention as there has been a continuous demand for such products by the consumers. Now, most important fourth one is after new breeding techniques like genome editing, genome selection, speed breeding, transgenics, and the diversification and valuation. Most important thing is adaptation to climate change. That is the need of the hour. The most common form of adaptation by farmers is use of new varieties. Farmers are going for new varieties which are tolerant or resistant to high temperatures or cold temperatures or whatever it may be, some stresses, acute biotic and abiotic stresses. New varieties farmers are going for. In addition to that one, adjusting planting dates, that's what we call it as the sowing window, selection of sowing windows, using natural pesticides, using organic fertilizers, altering the cropping patterns, intercropping, alternate wetting and drying, precision farming, improved tillage, integrated farming systems are needed to mitigate the negative effects of climate change. Farmers are going for all these technologies or technological interventions. Once again, for your academic interest, I repeat it. Farmers are adapting to climate change mainly through varietal selection. In addition to varietal selection, adjusting the planting times, that is sowing windows, using natural pesticides, using organic fertilizers, altering cropping patterns, intercropping, alternate wetting and drying, precision farming, improved tillage, integrated farming systems. Farmers are going for this one. Rice cultivation significantly contributed to climate change through methane. Therefore, efficient strategies are needed to limit the methane emission from the rice field. How we can do it? The application of anaerobic methanotropes to oxidize CH4 is an effective approach. For your academic interest, once again I repeat it. The application of anaerobic methanotrop to oxidize CH4 is an effective approach. Similarly, the development of high-yielding and climate-smart rice cultivators, by using different new breeding technologies, genome tools, genetic engineering, etc., need to be prioritized. Now, in addition to this one, these genetic interventions, genetic and plant breeding interventions, partnerships and linkages have to be developed a lot, and policies have to be changed. In the policy sector, what exactly needed are, India has a constitutionally empowered National Food Security Act 2013. It is to protect, the poor and needy consumers from food deficit and food crisis. We have constitutionally empowered National Food Security Act 2013. We have to meet the requirements of that particular constitutionally empowered National Food Security Act. The need of the hour is ensuring food security, reforms in minimum support price determination and implementation, decentralization of revamped public distribution system, storage and processing facilities to reduce the cost of procurement, distribution and storage operations is also has, this one also has to be covered under the policies side of our Food Security Act 2013. So these are the things that I would like to discuss with you. Here we discussed in the class what are the genetics. From genetic side, how we are, what is the state we are in. From the BITS point of view, I covered. Thanking you very much for your very patient hearing.